So, how do we set up a frequency distribution if we're only given the raw data? This is going to be a little bit more of an art than a science, as we'll see from step number 1 here. Decide on the number of classes you think will clearly represent the data. That's what makes this more of an art than a science. You have to decide what is going to give the clearest representation. Step 2, we'll calculate the class width. The class width will be the largest data value minus the smallest data value divided by the number of classes that we've decided on, and then rounded up to the next whole number. By the way, do you remember what we call the largest data value minus the smallest data value? We had a name for that. Yeah, that was also called the range. So another way we could express this formula is by saying the width is the range divided by the number of classes, rounded up to the next whole number. And as the note says, even if the above calculation produces a whole number, you should still go up to the next whole number to get the class width. Third, we're going to start constructing our classes by using the lowest data value as the lower limit of the first class. Now I said here you can use the lowest data value or something a bit smaller. Why would you want to use something a bit smaller? Well, for example, suppose your first data value was 2.1. You might want to instead use 2 as the lower limit, just so you have nice round numbers. But again, that just depends on what you think will best represent your data. After that, step 4, we can calculate the lower limit of the second class by adding the class width to the lower limit of the first class. Because remember, the class width is the difference between consecutive lower class limits. And then we just repeat for each class to get all the lower class limits. Then we fill in the upper class limits. And last, tally or count the data to determine the class frequency for each class. So here's an example. The heights in inches of students in a college classroom happens to be 66, 58, etc. I'm not going to read them all. And we want to construct a frequency distribution and then a histogram for this data. First decision, how many classes should we use? And there's a little hint here, the more data values, the more classes you should probably use. In this data set, we have 20 values, so probably 4 or 5 would be a good number of classes. I'm going to use 5 classes. There's no single right answer here. It's a decision as to what's going to help us best understand this data set. We're ready for the class width now. Remember, that was the range divided by the number of classes, which we've decided on as 5. For our range, let's see, the highest data value looks like it's 71, and I think the lowest one is 58. So 71 minus 58 is our range. That is 13, and 13 divided by 5 is 2.6. So we'll round up to 3, and that gives us the class width. Now we'll start building our classes. The lower limit of the first class can be either the lowest data value, which is our 58, or perhaps something a bit smaller. Now I don't see any particular reason to use something a bit smaller, so I'm just going to go ahead and use the 58. Then to get the rest of our lower class limits, we just keep adding 3 to them. So 58 plus 3 is 61, plus another 3 is 64, then 67, and then 70. For our upper class limits, each one is going to be the number right below the next lower class limit. So my first upper class limit is going to be 60. Why is that? Well, it's because 60 would be the next data value down from 61. Similarly, for the next upper class limit, I look at the following lower class limit, 64, so what would be the upper limit of the class previous to that? It would have to be 63. And then similarly, we'll have 66, 69, and 72. Now we tally how many data values are in each class. So the 66, that goes in the class from 64 to 66. The 58 is in the first class. We've got another 66, so that's again in the class from 64 to 66. Then we've got a 68, that goes in the second to last class. The 64 goes in the third class again. The 62 goes in the second class. 66 is in the third class, 64 to 66. Then we have a 63, that goes in the second class. 64 goes in the third class. 65 is also in the third class. 64 also in the third class. Another 64 for the third class. 62 is in the second class. 69 is in the second to last class, the one that goes 67 to 69. Then we have a 62 for the second class. We've got a 67 for that second to last class. Notice that if we had made the upper class limit for the third class 67, then when I got to that 67, I wouldn't know whether to put that in this class or this class. So that's why it's so important that the upper and lower class limits are not the same. Okay, moving on, we have a 63, that's in the second class. 66 is in the third class. 65 is also in the third class. And last we have 71, that goes in the last class. So our frequencies are 1, 5, 10, 3, and 1. It's easy to lose track of what you're doing when you're counting all these data values. So one check to get at least some verification that we did our count right is to add up the frequencies. And since we had 20 data values, we should have a total of 20 when we add up our frequencies. Let's see, 1 and 5 is 6, 16, 19, 20. So yep, that looks good. It doesn't guarantee that I didn't make a mistake somewhere, but at least it confirms I counted the right number of values. Let's do our frequency histogram now. The vertical axis, of course, is for the frequency. The horizontal axis will be for our classes. Let's see, what did our classes represent again? Heights in inches, yes. And we started with 58. What was our next lower class limit? 61. So again, it's only the lower class limits that show up in the histogram, at least in this style of histogram. There's more than one style, actually, but we'll stick with this one. It's probably the simplest one. Our frequencies go from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and our first class has a frequency of 1. Our second class has a frequency of 5. Remember, the bars do touch. Next class has a frequency of 10. Then we have 3. And last, another 1. I don't think I mentioned this before, but one way to see why we call the width the difference between consecutive lower class limits is when you draw your histogram, the width of each bar is 3. In this case, it's 3. Because by putting only the lower class limits on our horizontal axis, that means that the width of each bar is the difference between the lower class limits. So it's really natural to think of a width as something horizontal, which is why a really common mistake is to go horizontally on your frequency distribution table and say, oh, the width is 2, instead of doing it correctly, which is to go vertically and say the width is 3. So if you keep in mind that the width is also the width on the histogram, that might help you.